Okay, so next we will see there are three main things actually. We can consider 3 to 4. One is the instrument method, so we give the instrument a method so that it can use that method when it analyze our sample. The other one is processing method, so based on that method, the instrument method, the sample will be processed. So what is that processing method we will give it? So the next one is our sample itself, right? So the sample to be analyzed is the sequence, so we can create a sequence also. So that sequence will use this instrumentation method and this processing method. Okay, then the next one is report. Generally on report there are different report things, but we can use either of the reportings based on our interest, but generally we note down the area, so and we do our own calibration, but everything we can do here, the calibration, everything we can do here, but generally we don't do that. We just take the area reading and we do it on our own Excel sheet. So these are the major things. So first we will do we'll create let's start with instrument method, for example. So in the instrument method, this is our HPLC, so we just have to click on next. Then there is a runtime here. So runtime is basically how long your single sequence, which means single sample analysis, how much is this span time. So that's the runtime actually. So how we know this? Generally it's a fishy process, which means we will inject our sample, we will dilute and we will inject our sample, then we will see at what time or at what retention time our peak is appearing. Okay, so this is a trial and error process which takes a lot of time. So we will inject our sample, maybe it will be much concentrated, which we will see the peak will be flat at the top, so we will dilute it again and we will see like a sharp peak. Then once we see the sharp peak, 1 or 2 or 3, any component in our sample, then we decide based on the last peak appearance. So suppose we have 3 compounds, one is coming at 3 minutes, one is coming at 10 minutes, and the other is coming at 25 minutes. So RAMSAM we will set this at 30 minutes, so 30. So this is the way how we decide the runtime. Then we need all detectors and everything, so we don't touch anything here. Then we'll click on next. Then the other one is the mobile phase. So as I said before, we have 4 mobile phases, ABCDs for that 4 mobile phases. So you can give the name. For example, we are using only one at A, which is 0.05 molar molarity H2 SO4. We can give the name. So it's simple. So pressure limit we can put, which is the pressure maximum is 620 bar. So it will from 0 to here it is set by default. So upper limit, when it reaches this upper limit, it will give us an alarm actually. So let's leave it as it is, then we can go. So this is the flow rate. Actually we can do our flow rate. Flow rate is also, we can ramp our flow rate also based on our need, based on our runtime. Okay, so this is initially 0. So at a starting we can set it maybe 0.5 for example. Then again it will be 0.5, right here also it will be 0.5 because 0. Then from 0 to 20, for example, if we need ramping, so we can do insert row. Sorry, we can let me try again. So we can insert we can insert row. Then suppose we want 10 minutes. Okay, we want it let's say 6.6. okay, so 0.6, and at 20 means time from 10 up to 20, then at 20 till 20. So from 0 to 10, from like it will go by 5 ml per minute. Then next it will go by 6 ml per minute till 10 minutes. Then from 10 minutes to 20 minutes it will go by 6 ml per minute. Then at 20 we want it around 8. So we generally don't do these things, but this is helpful when our peak overlapping, this thing is happening. So if we want to play with temperature and flow rate at different timings, so we can play with it also. So we can delete or remove row or insert row, so we can do this. That's not an issue. So it's just for a demo purpose. I came up with some rubbish example, so we can do that also. Then after that, since we set the runtime 20 first, this is just stop run, right? So 20 will be our stop run. So that's why I say it's a rubbish example, because this will be less time, right, than this one. It's just to give you the perspective, like what its overall working process looks like. So generally we don't do that. Previous programs also, previous instrumentation methods you can see, but if you want, you can do this also. So we'll do next. This is the temperature. So temperature from 5 to 80 degree we can go. So generally we don't reach 80 degree. 50, 60 it is fine. So more than that we don't need. So to be on the safe side, we go till 70. So whenever you have a query about what it is, you can hover on the info, so it will give you the description. So I will leave it as it is, since well, let's see, we can make it, suppose I want to make it like 50. My analysis temperature is 50. Then next, so this is my RI detector. So RI detector, generally we don't touch anything, so I can give it maybe 5. Okay, 5 Hertz. I will give it this collection rate. So RI is generally, RI we use it for it's best for kind of sugars, so it gives a good detection, because the sugars have low absorbance for this UV, so RI will parallelly run. So it's better to use this parallelly. So that's why we are setting it. So we can play with it also. From papers you can see the information. Then we'll go next. So these are the UVVs. So these are ranges of UVVs. So depending on your product, its best detection wavelengths is also mentioned from literature. So some common ranges are there. You can try this. For it, it's significant, like plus or minus, you can say. So this is the significance. So pretty much it is this. So then we will next. If you have any comment, you can put any description, you can put here, then finish. So now our instrumentation